Hello and welcome back to Ganesh Institute. In today's video, we are going to talk about, can we change a matrix into a quadratic form? And is vice versa possible? Like, can we change the quadratic form into matrix? We'll talk about both of the things in this video, so stay tuned. Let's get started. So when we say quadratic form, you know that this is the form having degree 2, right? An algebraic expression having degree 2. So what do we require is, we need, so this is the expression, A is a matrix here. We want to have it in the form of X. So we need two things. One is a column vector. You can say eigenvectors. And another one is a matrix that has to be a square matrix. That means you know that it has to be of order m by m or n by n. And this matrix has to be a similar matrix. That is symmetric matrix. What do we mean by symmetric matrix? Whose transpose is equal to itself, right? So if you are having one matrix, and if you want to have that this is a square matrix, a symmetric matrix, and you want to have its quadratic form, then you can write it in the multiplication of X transpose A and X. Okay. For instance, let's say you have a symmetric matrix 2, 1, 1, 2. Is it a symmetric matrix? If you find its transpose, in transpose you change rows into columns. So here rows 2, 1 becomes column and 1, 2 second row becomes second column. And it is the same. So yes, it is a symmetric matrix. So what you will do, you will assume a vector, a column vector, and that will be of the same order. If it is having 2 rows, then there should also be 2 rows in the vector. Now, if you put in this value, so your quadratic form will be X transpose. So these 2 rows will be converted into, so these are 2 rows, these will be converted into 2 columns, right? And then here is your matrix. And then you have your X vector. Okay. Now if you multiply, so this is of order, this is 1 row, 2 columns. So 1 by 2. This is of order 2 by 2. And this is 2 rows, 1 column. Right. So if you multiply these two, your answer matrix will be of 1 by 2 order, right? Because in order to multiply, the column of first matrix has to be equal to the row of second matrix, and then the resultant will be this order, right? So 1 by 2 it will form, correct? So that means 1 by 2, first row 2 columns, that is first row 1 1 1 2 and 2 columns, this form. So first row first column is 2x1 plus x2 times 1. And then first row second column, so this is first row second column, x1 plus 2x2, right? And then here comes x1 x2, which is here. So now it is 1 by 2 and this is 2 by 1, so you will get 1 by 1 as an answer. So just simply multiply. So 2x1 this, so what will happen, you will multiply this by x1. So that means 2x1 square plus x1, 2x1 x2, x1 square plus x1 x2, right? And then what will happen? This one with x1. So x1 square, let me rewrite. What is happening here? You are multiplying this with first element and this with second, right? So 2x1 square plus x1 x2. Then this one with the next one. So x1 x2 plus 2x2 square, right? So you can see what is happening. You have got a quadratic form. This is your quadratic form. Have you got it? That how can we change a particular matrix into its quadratic form? Now there are three criteria. This quadratic form of matrix or only with the matrix, you can find out whether this is the condition of positive definite, negative definite, positive semi-definite, negative semi-definite, or indefinite. So what does it mean? I mean, what do we mean by all these conditions? So let me tell you firstly through quadratic form. If your quadratic form, this, that is x transpose ax, is greater than 0 for any such value, for all value of x not equals to 0. If it is greater than 0, then it is positive definite. If it is less than 0, then negative definite. Semi means you are including 0. So positive semi-definite means greater than or equal to 0. Negative semi-definite means lesser than or equal to 0. And indefinite means it is lying here and there. There can be two values, x naught, x1, such that when you are putting x naught, I mean such vector, you can get negative values. And if you are putting some other vector, you are getting greater than. So it is fluctuating, right? How can we check this? Let's see with an example. Let's say you have a matrix 1, 4, 4, 1. So it is a symmetric matrix. Let's say you have your vector as x1, x2. So what it will be having as its quadratic form? Again, qax will be x transpose ax, that is x1, x2, a, and then x1, x2, right? So if you multiply, you will get here, this is 1 by 2, this is 2 by 2, this is 2 by 1. So 1 by 2, right? That is A11, A12. So first row, first column. X1, first row, first column. X1 plus 4x2. Then first row, second column. 4x1 plus x2 times 1 is x2, right? This is one thing, and then here is x1, x2. So this has become 1 by 2 and this has become 2 by 2. So if you elaborate this by x1 and this by x2, right? So it has become x1 square plus 4x1, x2 plus 4x1, x2 plus x2 square, right? This is your what? QAX. Now you need to check whether this is the condition for semi-definite, indefinite, or definite. What you will do? You can simply convert it if you want into the completing square method. So that means you can have it as, you can see that it is 8x1, x2, right? If I want to make it a perfect square, I can do this plus 6x1, x2, right? Why? If you elaborate a square plus b square plus 2ab, so 2 and 6, those will be 8 only, right? Why I have converted into this form? Let's say my x1, x2 are 1 minus 1 or 1 1. Let's see what I'm getting as the value. If I'm putting 1 1, so this is x1, this is x2. Substitute here. 1 minus 1, that is 0. And this is 6 into 1 into minus 1, that is minus 6. So negative, negative means negative definite. But am I getting any other value also? So if I'm putting both of them as positives, that means 1 plus 1. This is 2 square plus 6 times 1 is 6. So this is 10, and which is positive. So it is giving me both of the values based on the vectors which I'm having. So it is not same for all sort of vectors. That means this is the condition of indefinite. Did you get it? So this is how you can check from the quadratic form. Like from the matrix, you form a quadratic expression, and then you check it for various vectors, whether it is giving you the answer or not. Now there is one another thing. Let's say you are having a particular quadratic form. You know that the matrix has to be symmetric, right? That means its transpose have to be equal to itself. Symmetric. Okay. Now let's say if I have to do, I'm given with a quadratic form and I need to make a matrix out of it, and then need to tell that whether it is the condition of indefinite, definite, or what, semi-definite. So how will I do that? Let's say the quadratic form is, the general quadratic form is ax1 square, because it has to be of degree 2, bx2 square, cx3 square. So you can see I have three vectors here. So that means my matrix is going to be 3 by 3 order, right? Then 2d x1 x2, 2e x2 x3, 2f x3 x1. What is happening? I have deliberately considered this value 2d, 2e, 2f. You know why? See, I'm making a general matrix from it. All these vectors, the square and their coefficient, these leading coefficients means the coefficients with highest power, A, B, C, will be the elements of principal diagonal. So this is ABC. Then you can see this 2D is the coefficient of x1 and x2. So this is x1, this is x2 column, right? So half of it will go here. Not 2D, but half of it. Then x2, x3. This is my x2, this is x3. So you will place the value like this, okay? So you'll place it this way in diagonal form. Okay, so it is half of 2e, that is e and e. And then x3, x1. So x1 and x3. So here you will place half of f. This is the trick which I'm telling you to make it in the matrix form. Okay. Then what you will do to find out indefinite, semi-definite, and definite? You find out the principal minors. You know what minors mean, right? If not, you can check out that video where I have explained minors, but I'm explaining here also. This is first order minor, wherein you need to consider only the first element. Only this first element. Then you will find second order minor. This second order minor will be the determinant of the 2 by 2 matrix. What is this? PV. Then you will find third order minor. That will be the determinant of all of it, the whole matrix. If all of these D1, D2, D3 come out as positive, then you will say that it is a condition of positive definite. If they come out as less than 0, then negative definite. And if they are including 0, then this is the condition for positive semi-definite. D1, D2, D3 including 0, it is less than 0. Then it is the condition for semi-definite, negative semi-definite. And then if one is positive, one is negative, something like that, then it will be the condition for indefinite, right? Can you see this is a symmetric matrix? If I transpose this, my first row is ADF. So this will become my column. This is DDE, second column. Third row will become third column, FEC. But look, it is the same. So that means it is a symmetric matrix. So I've explained to you the process. Let me take you through the example. So let's say you have one quadratic form, okay, and you need to find out whether it is the case of definite, positive definite, negative definite, semi-definite, indefinite, what? So you first create the symmetric matrix. I have told you, remember the sequence. Sometimes they give you x2 first, x3 later on. So you need to check the order also. So these coefficients become your principal diagonal elements. This is x2, x3, x2, x3. So half of it, that is 3, will go here in this form. Then half of x3, x1, x3, x1. That means where? Half of it is -5. And this is x1, x2. Half of it is -2. So this is your symmetric matrix. Now you can find out the principal minor. First, D1 is first element, which is greater than 0. Then the determinant of these 4 elements, your second order minor. There is some different thing when we calculate minor, but here we call it second order minor using this way. Now how to calculate the determinant? 10 times 2 is 20, minus is in the formula, and this is -2 times -2, that is +4. So 16 again greater than 0. D3 is the determinant of whole of it. So this has become 10 times this. 5 2s are 10 minus 3 3s are 9, right? Okay, then we have -2. Minus is in the formula, -2 becomes plus, and then you hide the row and column in which it lies. So the determinant of 5 times -2, minus is in the formula, -5 times 3. And then you have third. So what you will do? You will hide the third row and first row and third column in which it lies, the -5. And then you take the determinant of rest. Minus is in the formula, 5 2s are 10. So 10 minus 9 is 1, 10 times 1 is 1. 15 minus 10 is 5, 5 times 2 is 10, 10 minus 6 is 4, 5 20. It is 0. So because it is including 0 and rest of the elements are greater than 0, so it is the condition of this. That means positive semi-definite, right? So this is how you can calculate using the quadratic form, then converting into the matrix form, that whether it is what? Whether it is semi-definite, positive definite, or what. Then there is another thing. Let's say you are given with a matrix 1 5 2 4. Let's say you don't know what is quadratic form, you don't know what is, other things which I have explained to you. Then there is another thing, using eigenvalues or eigenvectors, you can find out. Just to tell you, eigenvalues are scalar values which tell the magnitude of the quantity, and eigenvectors are vector values, they provide you the direction. For example, I, j, k cap, you know that I is in x direction, y direction, k direction. I mean x, y, z direction, right? 3D plane. Anyways, coming back to this is this matrix. You know how to calculate the eigenvector and values, right? You form a characteristic equation first. So you do A minus lambda determinant 0. A is nothing but your matrix, minus lambda is the scalar value, which is the eigenvalue, and I is the identity matrix of the same order as that of the matrix given. Then you multiply 1 minus lambda, then 2 minus lambda 0, 5 minus lambda times 0 is 5, and 4 times minus lambda. And if you take the determinant, that is 1 minus lambda into 4 minus lambda times 0. So you'll see you get lambda by putting it as 0 is 1, this as 4. So these are your two eigenvalues, right? Is this correct or not? This is 2, right? Oops, my bad. So if you recalculate it, this is 1 minus lambda into 4 minus lambda minus 5 to the 10. If you elaborate, 4 minus lambda minus lambda, 4 lambda minus minus plus lambda square minus 10. So this becomes lambda square minus 5 lambda minus 6. So this is the quadratic equation. You can solve it using the splitting the term method. So this becomes 6 and minus 1, right? And then you can calculate what vectors from it. You know how to calculate vectors? You can simply multiply A minus lambda I into x. Okay? So when your lambda is 6, what can you do? If your lambda is 6, then you will place here A minus lambda is 1 minus lambda, 4 minus lambda, 5 2, right? This is your A minus lambda I form. So if you place lambda as 6 here, 1 minus 6 is minus 5, 4 minus 6 is minus 2. And then your column vectors x1, x2 equals 0. Then you can find out the value of x1, x2 by having two equations. So minus 5, first row, first column, minus 5x1 plus 2x2 equals 0. 5x1 minus 2x2 0. So you can see that here your x1 is minus 2x2, right? Correct? So if you are placing it, your x1 becomes plus 5x1. If you take to that side, this has become plus x1 by 2. You can take this 2 downwards, and then in denominator 5. So these are your two vectors, x1, x2. These are positive, right? And then similarly, you can get it for lambda minus 1, right? And using that also, you'll be able to get whether it is positive definite, negative definite, and semi-definite. Okay. Remember, if eigenvalues, if both of the eigenvalues are positive, then it is the condition for positive definite. If your eigenvalues are negative, then it is the condition of negative definite. If they are including 0, then this is the condition for respective semi-definite. Because here you are having both positive and negative values, so this is the condition for indefinite. So I have explained to you overall 3 ways of checking the conditions. One, using quadratic form of the matrix. Second, using the matrix by using the principal minors. And third, using eigenvalues. I'm hoping that the video is clear to you. I mean, the concept. And if so, then don't forget to like, share, and subscribe my channel. Till my next video, take care of yourself. Bye-bye.